Okay, so the focus for today is once again on linear inequalities, but today is going to seem a bit different than the last class. We're going to be solving linear inequalities today, so this is going to look a lot more like solving linear equations, which is what we were doing before. Basically, that's where you just get x all by itself. Anyway, let's get started here. Here's today's plan. We're going to review linear inequalities from last class, so the same kind of idea that we were doing yesterday, but then, like I said, we're moving on to solving linear inequalities, which again, like I said, is basically the same thing as solving a linear equation. While we're doing this, I will introduce a really, really important rule for these. There is one real key situation in which linear inequalities are different than linear equations, at least in how you solve them. But we'll get to that when we get to that. And then I'll also throw a word problem in there just because, you know what, we need to have fun sometimes, right? Right? No, just kidding. Anyway, let's move on. Here we go. So represent the following inequality with a number line. 17 is greater than x. I would really appreciate it if you just pause the video here and give this question a try on your own. All right, I'm going to go over this one now. You can do this one way or another, but personally what I always like to do, as I mentioned last class, was I like to write it so that x is written first. Now, if you think of this inequality sign as being a mouth that's eating the bigger number, we can just switch this around and just say x is less than 17. The inequality sign, or in other words, the mouth, if you want to call it that, is still facing, trying to eat the bigger number here, that being 17. Now, the reason I like writing it like this is just at least personally, my mind is, it just interprets this a little bit better than writing it the other way around. It's easier for me to think x is less than 17, so we have a number that's less than 17, than it is for my mind to think about 17 is bigger than some number, right? Maybe it's just me, maybe I'm just talking for myself here, but it's just how my mind works. Anyway, if we're going to graph this on a number line here, we just take a number line. Since there is only one point we're comparing it to, that being 17, of course, we put that right in the center of our number line. And then we go to the left when we go smaller, and we go to the right when we go bigger. So we'll go 16 here, then 15, and then 14 over here. And then I guess likewise, we'll say 18, 19, and 20. Now, since x is less than 17, we want to shade the entire part of this number line that's underneath 17. But there's another important thing we have to remember as well. Notice this is just a strictly less than sign. It's not less than or equal to. Because of that, we have to put an open circle at 17 because that tells us we can't actually include 17 as being a value of x, but we're just going to get really close to it. So put an open circle around 17 because it's strictly less than, and then just shade below that line. Now, another really big reason why I say sometimes it's nice to have your x first is because then you can think of your inequality sign almost like an arrow showing you which way to shade. It's kind of a cheap trick, but at the same time, it works if you want to remember it that way, right? I guess the only other thing I'll say there is if this were instead a less than or equal to sign, instead of an open circle, we'd have to do a shaded in circle, or in other words, a closed circle. And that would be because in that case, we would be including 17 as one of our possible x's. In this case, though, we're just saying x is strictly less than 17. So if x were 17, it would not be a solution to this problem. Anyway, moving on. All right, so I want you to show algebraically with a number line this absolutely horrifying situation here. Watch this. Woo, they're all gone, right? So I want you to show algebraically and with a number line an inequality that shows how many cats were potentially given nightmares in this clip. We can watch it another time here. Count the cats. And boom, they're all out of there, out of the crib. I don't know why, like it looks like he's got like cat chows in the crib. I really don't think that's a good idea, having cat chows in a crib. That's kind of unsanitary. But anyway, we counted 5 cats there. So the amount of cats that were potentially given some nightmares in this clip is going to be, well, anywhere between 0 cats and all 5 cats. It's probably going to be all 5 cats. Let's be honest here. I think these cats are going to be traumatized for life from this absolutely horrifying event. Like I'm just traumatized looking at this guy. Like I don't know where he got that mask from, and I don't really want to know. But anyway, we know that the number of cats traumatized by this horrible event, like I said, is going to be somewhere between 0 and 5. Now, if we're going to say that x represents the number of cats given nightmares in this clip, we'll put it right in the center. But then we have to be really careful which way we draw our inequality signs. Remember, we have less than, and we have greater than, and we also have less than or equal to, or greater than or equal to. This is where you have to be thinking a little bit logically here. 0 is going to be our lower bound here. right? It's going to be our lowest possible number of cats that we have. Now, theoretically, 0 of these cats could have nightmares. Maybe they just got over it. Maybe they just forgot about it. Who knows, right? So maybe we could include 0, but x definitely needs to be bigger or equal to 0. So we want to make the mouth way, like if you want to think of it that way, the mouth facing the x here. So in other words, we'll put it this way, because x needs to be a bigger number than 0, or in other words, 0 has to be less than x, but it could be equal to. So we'll put the equal to part sign underneath it as well. Likewise, x could be anywhere up to or including 5, but it can't be more than 5 because there's only 5 cats in here. So we're going to say x is also less than or equal to 5. So if we read this out just by saying it out loud, we would say 0 is less than or equal to x, which is less than or equal to 5. I'll say it again. 0 is less than or equal to x, which is less than or equal to 5. That's basically how we'd have to get this one done. Now, if we're going to do this with a number line, let's just draw the number line first. Remember, this is a two-part number line because there's two potential numbers in here, 0, which I'll put way over here, and 5, which I'll put over here. Give yourself a little bit of wiggle room, so we'll say -1, although really that doesn't make any sense in the context of this question. And we'll say 6 over here. And then I guess that just means we have 4, 3, 2, 1. So I'll even fill that in. 1, 2, 3, 4, 5, 6. There we go. Now, because we could potentially include 0 and 5, we need to put closed circles at both 0 and at 5. And then, of course, because we could be anywhere in between this, we're going to need to shade the line that's in between. So using a number line to represent the amount of cats being traumatized by this clip, and I just find it funny just how many times this clip has been playing as I've been rambling on here. It's anywhere between 0 and 5. So that number line is another way of expressing this. And that's the whole point of this. That's the whole reason we're doing number lines. It's just another way of expressing this. And it's getting us to think about certain situations in different ways, ways that maybe you haven't thought of before. This is a ridiculous example. This is absolutely crazy, but I thought, you know what, this is funny. I need to incorporate this in here somehow. Anyway, moving on. Solving inequalities. This is where things get way more important. All right. And the good news is it's very much like the stuff we were doing last week. I mean, I guess I should say before the holiday. Now, just like linear equations, linear inequalities can be solved. Basically, this just means isolate x, or in other words, get x all by itself, just like it did before. Unlike equalities, however, though, solving inequalities doesn't provide a definite answer for x, but rather a range of possible solutions. When you solved a linear equation, we would find that x would equal some certain number. For example, maybe x would equal 4. It would be one exact number. You'd have one solution to it. With inequalities, you're just saying that x is either greater than or less than, or greater than or equal to, or less than or equal to some number. So in other words, you're going to have a huge range of possible solutions, but you just want to figure out what that range is. So the rules are exactly the same for solving inequalities as it was for solving equations, just with one small exception, which we will discuss a little bit later, but let's focus on the basics first before we worry about these weird exceptions. So let's start with this example here. 4x is greater than x plus 12. So 4 of some number is bigger than that same number plus 12. We want to find what that number could be to make that true. Now, you can't just guess and check these. You have to find that whole range of possibilities. If you pretended that this greater than sign was the same thing as an equal sign, you could solve it the same way that you would do it before. In other words, we want to isolate x, or in other words, get x all by itself. This is one of those questions where we have x on both sides of the inequality. Same idea as if x was on both sides of an equation. When that happens, you want to gather all of your x's to one side. And like I mentioned in previous videos, you'd want to do that by moving the smaller x over. So how about we move the x over here, because technically this is just 1x. So let's minus x from both sides. What that's going to give us is going to give us 3x, because 4x minus 1x is 3x, is greater than positive 12. Now we want to completely get x all by itself. So the next step to do is we want to divide by 3 on both sides. So if you divide both sides of this by 3, you're going to find that we now have x is greater than 4. And since x is now completely by itself, we can put a box around this and say that is going to be our solution. X just needs to be a number that's greater than 4. That's what's going to make this original inequality true. Now, on a normal question, you don't have to go any further than this. You found the solution because you got x all by itself. You're good to go. But just to really illustrate what this means, let me show you by proving to you that this will work. I'm going to plug in, how about we say x equals 5. If I plug x equals 5 into this inequality, it should work because we found that our solution is just any x greater than 4. Since 5 is greater than 4, it should be something that works here. But let's test it, just to be sure. If x was equal to 5, we would have 4 times 5 is greater than 1 times 5, so just 5, plus 12. Well, let's see if this is true. 4 times 5 is, of course, 20, is greater than 5 plus 12 is 17. So we have an expression that now says 20 is greater than 17. Is that a true expression? I certainly hope it is, right? So 20 is greater than 17, so we can put a check mark here. Yeah, it totally worked. Now let's check for an example that wouldn't work. This says that the answers that are x is greater than 4 are going to be things that work here. How about we pick a number that's less than 4, so something that isn't part of this certain range. So how about we say x is equal to 3. So by this answer here, x must be greater than 4, x equals 3 shouldn't work. Let's just double check though. 4 times 3, because remember we're using this equation over here, 4 times 3, we want to see if that's greater than 3 plus 12. Well, 4 times 3 is 12, and we're saying that that's greater than 3 plus 12, which is 15. So the expression 12 is greater than 15, clearly that doesn't make any sense, right? So in other words, x equals 3, that is not a possible solution. So it's pretty curious. You went from just 3 to 5, and all of a sudden you had a correct answer. It's almost as if, this works, right? So you don't ever have to check this. I just did this just because, why not? I'm just showing you that there's a whole range of possibilities. To really drive it home, I could say, okay, now let's check x equals 6. Guarantee, I totally promise you right now, it'll work. X is 7, totally it'll work. X is 497, it'll work. Any number greater than 4 is going to work in this case. Anyway, moving on. All right, here's a couple more we're going to solve. We'll do these ones together, or rather, I'll show you how to do them. If you want to pause the video here and try them on your own, by all means, go for it. But aside from that, let's get these ones done. On this first one, x is on both sides of the equation, but this is one of those tricky ones where x is locked away inside some brackets here. And that just poses an extra challenge for us. That just means we have to get rid of these brackets so that x is more free to move around. Because we can't literally just minus x here. It's locked away in brackets. This 2 on the outside is dictating what's going on to it. So I'm going to start by taking this 2 on the outside and I'll double dip it through. This is going to give us 3x plus 2 is less than or equal to 2x minus 2 times 4 is 8. This x is no longer locked away in some brackets. It's now free to move around. So how about we minus 2x from both sides? This allows us to gather all our x's on one side, of course, and that leaves us with 1x plus 2 is less than or equal to negative 8. And again, it's negative 8 because this minus sign didn't just disappear. It's still going to be there, so it's minus 8. Last thing to do here is we want to get x totally by itself, so we're going to have to minus 2 from both sides. This is going to give us x is less than or equal to negative 8 minus 2, which is negative 10. So x must be less than or equal to negative 10 in order for this original expression to work. If you're ever not sure, you can always start plugging some numbers in here. So a number that's less than or equal to negative 10 would be maybe negative 11, right? You could plug negative 11 in here and see if it works. I'm pretty confident it's going to work, so we don't have to worry about that. But if you ever want to do that, by all means, go for it. Next one, this one has fractions in it. That's everyone's favorite thing in the world. Personally, I'm going to use that trick that I introduced just the other day. When you have fractions involved in an equation, or in this case, an inequality, it's probably easiest just to multiply everything, like every single term, by the denominators. That way you clear the denominators out and you don't have to worry about using fractions anymore, right? So we'll start with this fraction here. We got 4 over 5, so let's multiply it by 5. That gets rid of the denominator. But you can't just multiply one thing by 5. In order for this to stay balanced and still true, every other term needs to also be multiplied by 5. Okay, so we're staying consistent. Everything's getting multiplied by 5. It's just getting scaled up. That's all that's going on. Now, the other thing we got to do here, might as well do it all in one step, is we want to get rid of this divide by 3. So let's multiply everything by 3, including this, of course. That just knocks out the 3. That's the whole reason behind doing that. And then we have to multiply this thing by 3, this thing by 3, and this thing by 3 as well. So let's take this one step at a time. Let's worry about 6x. 6x times 5, well, that would be 30x. 30x times 3, that's 90x. So we have 90x plus 4 over 5 times 5, that got rid of the 5 there. So we just have 4 times 3, well, that's just 12. So we have 90x plus 12 is greater than negative x times 5 is negative 5x. Negative 5x times 3 is negative 15x. And then we have plus 13 times 5. 13 times 5, I'm pretty sure, is 65. Okay, so as always, move the smaller x over to the other side. The smallest x here is this negative 15x. To move negative 15x to the other side, I'm just going to add 15x to both sides. There we go. That's going to give me 105x plus 12 is greater than 65. The next thing I want to do is I want to move this 12 over so we can get x more by itself. So if I minus 12 on both sides, I have 105x is greater than 65 minus 12, which is 53. And then we have to divide both sides by 105 to get x totally by itself. So this is going to be kind of a crazy answer. X is greater than 53 over 105. That is a really bad answer. Like, that is really not nice, but you know what? Might as well leave it there. Now, typically, we should try to reduce the fraction. Just looking at this off the top of my head, I don't think there's anything that's going to go into both of these. I could be mistaken, though. Let's just check. 53 over 105. I was going to say 17. Does 17 go into 53? No, it doesn't go into 53. I think 17 goes into 51. I'm just trying to pick some weird numbers here. I really don't think so. We'll leave it at that. If it does simplify, which I really don't think it does, I'll try to get back to you at some point on that one. But I'm pretty sure that that's it. And that would be a valid answer. So x just needs to be bigger than 53 over 105. And just because it's worth mentioning as well, I wouldn't change that into a decimal. I know a lot of you guys are a little trigger happy when it comes to decimals and all that. But if you did 53 over 105 as a decimal, I'm going to just check it right now. Oh, it's horrible. It's like 0.5047619048. It's awful, right? So when you have an awful decimal, just leave it as a fraction. It is way easier to communicate it as a fraction than as an absolute nightmare of a decimal. And the last thing we want to be doing is rounding things off, because that makes it not really a genuine answer. It just makes it a rounded answer, which isn't ideal. Anyway, here's that super important rule that I was mentioning earlier. Okay, so now we got a little bit of practice with this. Hopefully this super important rule will ring a little bit more true in our minds. So far, all of these examples we've done have been the exact same as equalities. If all these other examples, we just replace the inequality sign with an equal sign, we would have solved it the exact same way we've been doing this whole time. Nothing's been different. There is, however, one crucial difference when you're dealing with an inequality, and I cannot understate how important it is that we understand this rule. Hence why I put super. You know I don't use the word super very often. Maybe I do, I don't know, but still, it's a really important rule. Here's the rule. If you multiply or divide both sides of your inequality by a negative number, then the direction of the inequality sign changes. It's a weird rule. It's kind of hard to explain why this rule exists. I can show you by an example why this rule exists. It's just really bizarre, but just take my word for it. If you ever have to multiply or divide both sides of your inequality by a negative number, the direction of your inequality sign is going to change. It's not going to become an equal or less than or equal to or anything like that. It's just going to flip around. That is all that's going to happen to it. This example is a perfect example of this. Negative 4x is greater than 16. From the other examples we've done, we know we had to get x all by itself. So logically, the way we'd have to do this in this question is divide by negative 4 on both sides. Now, right now, that hits this rule. We are dividing both sides of this inequality by a negative number. So as per this really crucial rule, we have to flip the sign around. So x, or rather negative 4x divided by negative 4 is going to become positive x. But since we divided by a negative number, this greater than sign is going to switch around to a less than sign. And then we have 16 divided by negative 4, which is going to be negative 4, coincidentally enough. So x is less than negative 4. That is going to be our answer. And if you don't believe me that this works, let me show you another way you could do this without actually using this really important rule. If instead of doing this, let me just rewrite it so we can start over. If instead of doing this rule, you said instead, okay, we have negative 4x here, that's just kind of awkward. Let's start by adding 4x to both sides. That would give you 0, because there's nothing left over here. Negative 4x plus 4x totally cancels each other out. You're just left with nothing. 0 is greater than 16 plus 4x. And then maybe you're like, okay, you know what? We want to get x all by itself. We're not going to play around anymore. Let's move 16 over. So you minus 16 from both sides. That would give you negative 16 is greater than positive 4x. And then, of course, the last step you'd have to do here is divide by 4. So if you divide by 4 on both sides, it's not negative 4 this time around. It's just like positive 4, right? You're going to have negative 4 is greater than x. Now watch the direction of the mouth there. The mouth is trying to eat the negative 4, so you might as well rewrite this the other way around. X is less than negative 4, which is the exact same answer that we got over here. Whew, spooky, right? So the rule is really important. It basically saves us the time and effort of moving x's over to the other side, but still really important to know. Make sure you don't miss that. It's every single year. People always miss that rule. Really important to understand. All right, so we have a few more questions we're going to solve here. You probably could try these ones on your own, and I would really recommend it. So if you feel up to it, pause the video here, give these ones a try. So if you felt up to it and you did it, kudos to you for trying. If you didn't, that's okay, we're still learning. So negative 3 over 4x is less than or equal to 5 over 4. We want to get x totally by itself here. Now, you could use that rule I mentioned before where we just multiply both sides by whatever denominator you had. That would work just fine. But personally, because it's only one fraction attached to x here, it's probably unnecessary. To get rid of this negative 3/4 times x, let's just divide by negative 3/4 on both sides. And that'll take care of that right there. However, we just divided by a negative number. So that means we have to flip that sign around. So this is going to become x is greater than or equal to 5 over 4 divided by negative 3 over 4. Well, hopefully we remember when you have a fraction divided by a fraction, that's not very good, right? We want to keep, change, flip it because we don't know how to divide fractions directly. We have to go keep the 5 over 4, change to a times, and then flip so it's 4 over negative 3. This is going to become x is greater than or equal to 5 times 4, which is 20, over 4 times negative 3, which is negative 12. Couple things about this. First of all, we hate having a negative in a denominator. So in the next step, I'm going to move it to the numerator. The other thing we see here is we can simplify this fraction. A number that divides both 20 and 12 is 4. So if we divide the top and the bottom by 4 to simplify this, we have x is greater than or equal to, move the negative to the top. 20 divided by 4 is 5. 12 divided by 4 is 3. Negative 5 over 3 is as simple as we can go with this. So that would be our answer for that one. All right, next one here. Negative x over 7 is less than negative 2 over 3. This one's actually, in my opinion, believe it or not, actually easier than the one we just did. Because we can actually think of this negative over here as being just a negative on the 7 on the bottom. And we'll just say it's like x over negative 7. Now, I know I just, like literally just said having a negative on the denominator is kind of not good. It's not ideal, but it means the same thing. And believe me, for this one, it's going to save us an extra step for solving this. So if we just imagine that as being negative 7 on the bottom, because it doesn't matter where that negative goes, whether it's on the top or the bottom, it's just by convention, we like putting it on the top. This allows us to see to get x all by itself, we just have to multiply both sides by negative 7, because that gets rid of this divide by negative 7 here, right? So if we multiply by negative 7 on both sides, that gets rid of this here. But look at that, we multiply both sides by a negative number. That means we have to flip the sign around. So it's going to become x is greater than, now negative 2 over 3 times negative 7, which is like negative 7 over 1, is going to be negative 2 times negative 7, which is positive 14, over 3 times 1, which is 3. And you can't simplify that fraction. 14 over 3 is as simple as it goes. So we'll leave that as x is greater than 14 over 3. Whew, this has been a long lesson so far. A couple more slides, I think. I think this is actually the last one. Oh, it is the last one. Okay, perfect. All right, just a word problem. Last question to get through, guys. We've almost made it. And it's a bit of a riddle kind of question, if anything. And I do want you guys to try this one. I'm thinking of two numbers that when added together are less than 74. Now, one of the numbers is 8 more than the smaller number. I want you to determine the possible values of the smaller number and the larger number. This is a good problem-solving based question. It really gets you thinking critically. Pause the video here, see if you can solve this. Okay, let me show you how I would go about solving this question. We know we have two numbers. we could say right off the bat, we could say those two numbers are x and y. Now we know when we add these two numbers together, x plus y, that number that adds it together is less than 74. So you even might as well write that using an inequality sign. It's less than 74. So two numbers, x plus y, is less than 74. Now here's the catch though. One of the numbers is 8 more than the smaller number. How about we say y is that number? So how about we say y is equal to x plus 8. So y is going to be 8 more than the smaller number. It's the smaller number plus 8. Since we know that y is equal to x plus 8, we could just rewrite this x plus y as x plus, instead of y, we could call it x plus 8 is less than 74. Now watch the trick here. It's a very clever trick. We have x plus 8. If you thought of this as 1x plus 8, you could now think of this as saying 2x plus 8 is less than 74. And what do you know? Now we can actually solve this because now it's just a normal linear inequality. So we can minus 8 from both sides. And that's going to give us 2x is less than 74 minus 8, which is 66. And then just divide by 2 on both sides. And you have x is less than 33. So your smaller number, which we said was x, is going to be less than 33, which means your bigger number must be less than a number that's just 8 more than this. So it must be less than 41, because 33 plus 8, because it's x, or y is 8 more than x, y just has to be less than 41. Now it can be equal to 41 and it can't be equal to 33 because 41 plus 33 is exactly equal to 74. And it does say it has to be less than 74, not equal to 74. So even if we chose y was 40 and x was 32, well, 32 plus 40 is of course 72, and that does fit the criteria. It's going to be just fine, right? You could even go negative with this. You could choose like, I don't know, y is -1, and then x would be 8 smaller than that, so -9. -9 plus -1 is -10. That's way less than negative or than positive 74. It's crazy. Anyway, that's it. We're done. Whew, thank goodness. And that's the last of our online lessons, hopefully for the rest of the school year. This was January 9th lesson, or January 8th lesson, of course. So hopefully that was it, but who knows? We never know. We may be back. But for practice, I want you guys working on these questions. The first group of questions were from last class, and I think most of you guys already got those done. But the second group of questions are new, and that is definitely where you want to be putting your focus on these page 357 questions 5 to 7, 11, 12, 14, 15. It sounds like a lot. It shouldn't take you too long, though. Don't worry. Anyway, you know how to reach me. I am in this Zoom this entire time. If you need me, best of luck.